The idea of sending humans to Mars has been a dream for both scientists and visionaries for decades. Thanks to advances in space technology and growing investment in interplanetary exploration, this dream is closer to becoming a reality. However, achieving this goal is a complex challenge that involves overcoming scientific, technological, economic, and ethical obstacles. Below, we break down the current possibilities and the main challenges associated with this historic mission. The race to reach Mars began as an extension of the space program initiated in the 20th century. While the Moon was the first objective successfully reached by humans' Apollo program, 1969, Mars has remained the next great challenge due to its distance, hostile atmosphere, and the need for entirely new infrastructure. Currently, several space agencies and private companies lead the planning of manned missions to Mars. NASA, through the Artemis program and its long-term vision, is developing technologies that will enable human missions to the Red Planet in the 2030s. SpaceX, under the leadership of Elon Musk, is building the Starship spacecraft, specifically designed to transport humans and supplies to Mars, with an ambitious goal of establishing permanent colonies. The European Space Agency, ESA, while collaborating with NASA, also has an interest in future manned missions. China and Russia both have active projects considering the possibility of reaching Mars in the near future. Technological advances have made it possible to seriously consider a manned mission to Mars. Some of the most relevant developments include systems of interplanetary transport and reusable rockets. SpaceX has led the development of reusable rockets, which drastically reduces the cost of launching missions. Advanced spacecraft like SpaceX's Starship promises to be an efficient solution, capable of carrying multiple astronauts, supplies, and colonization equipment in a single launch. One of the biggest challenges in deep space is cosmic radiation. Current missions are investigating protective materials, underground habitats, and technologies such as superconducting magnets to create magnetic shields that protect astronauts. Mars has a thin atmosphere, composed mainly of carbon dioxide, and extreme temperatures ranging from -125 degrees Celsius to 20 degrees Celsius. This necessitates the development of pressurized habitats, advanced spacesuits, and systems that convert CO2 into oxygen. To reduce dependence on Earth, technologies are being developed to extract water from the Martian polar caps or soil, as well as to produce fuel using local resources, methane and oxygen from the CO2 in the Martian atmosphere. Despite the advances, numerous obstacles still remain before humans can reach Mars. Mars is at an average distance of 225 million kilometers from Earth. A journey could last between 6 and 9 months, exposing astronauts to prolonged periods of isolation, microgravity, and radiation. The effects of microgravity on muscles, bones, and cardiovascular systems are well known. But on a mission to Mars, astronauts will also face psychological risks due to isolation and uncertainty. Carrying enough food, water, and oxygen for a round-trip mission is unfeasible. So it will be crucial to develop technologies that allow for food cultivation on Mars and efficient resource recycling. The estimated cost of a manned mission to Mars ranges from $100 billion to $500 billion, which requires international collaboration or significant advances in cost reduction. Ensuring the safe return of astronauts to Earth is a technological and logistical challenge that has not yet been fully resolved. SpaceX plans to conduct test flights with the Starship, including possible unmanned missions to deliver cargo to Mars between 2024 to 2026. NASA and SpaceX are expected to collaborate to conduct the first manned missions between 2030 to 2035. This timeline will depend on the success of preliminary tests and government funding. If the initial missions are successful, permanent bases on Mars are planned, which could evolve into self-sufficient colonies by 2040 onwards. Sending humans to Mars is not just a symbolic achievement, but offers scientific, economic, and social benefits. Direct study of Mars could reveal evidence of past or present life, helping answer fundamental questions about the origin of life in the universe. The development of technologies for Mars has direct applications on Earth, from renewable energy to life support systems. As occurred with the moon landing, a mission to Mars could unite humanity around a common goal. While the challenges are enormous, the possibility of humans reaching Mars is more realistic than ever. The combination of technological advances, international interest, and leadership from the private sector suggests that we could see humans on Mars in the next 2 decades. However, this achievement will depend on meticulous planning, rigorous testing, and a global collaborative effort. If achieved, it will mark a new chapter in the history of humanity, opening the doors to deep space exploration and the possibility of becoming an interplanetary species.